Yo, what's up, everyone? Week 6. I don't have that much more to say, other than I hope this is going to be a pretty quick lesson, but also a good lesson. So I really like this stuff, and I've been really enjoying thinking through my lessons even harder with online school because I have like even more time to kind of master them. So I'm pretty sure I'm teaching all this stuff really well. So get excited for that. But first, we're just going to do two problems today. It says, look at the following two scatter plots, which attempt to predict test scores along two measures, problem set completion and quiz scores. So you might notice this worksheet looks kind of wide, and that's just because I wanted to make these two scatter plots back to back look as big as possible. And we know that what a scatter plot does from yesterday is it takes two different pieces of information about each of its data points and plots them together as if it was like a coordinate, like an XY coordinate. Okay, so each dot would represent a student in this case. Okay, so I wasn't clear on the sample size or anything like that, but each dot is saying that this student had a 25% on the problem sets and a 25% on the test averages. Okay, so again, each dot is a data point here. And we have two, which are both testing the same thing, which is test average, but they have different bottom variables, and we're going to talk about that. Plus, we have the regression lines. So first, A says, what are the independent and dependent variables of each scatter plot? And hopefully, this is not new to you, but we know that when we have a graph, we have an X and we have a Y, and we talked about this a little bit yesterday, but we always know that the basic idea of a function is you input an X value and you find a Y value. And that's going to be the same thing for our scatter plots in statistics. Okay, our X value is going to be used to predict our Y value always in a scatter plot. Okay, so if it asks you what are the independent and dependent variables, independence X, dependence Y, just like every other class, and the logic is going to be the same. Okay, but in this case, think that both of these we're trying to figure out essentially what makes students do better on tests. Do the quiz scores matter more, or do the problem sets matter more? And to figure that out, we have to figure out what's happening with our two independent variables. Okay, so problem set average and quiz average are the two independent variables, but then the dependent variable, what we're testing, is the same for both, which is test average. Okay, so again, if you ever ask these things, you always just kind of look at what's X and Y. And again, we're starting really easy here. That was something I kind of could have given you yesterday. And B and C, I also could have given you yesterday, so I'm going to go through them both pretty quickly. But what B says is, if a student does 50% of the problem sets, what does the regression line predict? And I changed the wording of this on purpose because in different places they call it a different thing. We called this the line of best fit yesterday, but another word for it is the regression line. Okay, and we know that this line predicts the test average based on the problem set average. So we can plug in 0.5 into the equation and solve for Y. So I'm going to do that for both of these, which is just what we did yesterday, and then we'll move on from there to the new stuff. Okay, so using the regression lines, I found these two, and both of these are predicting what the test score is going to be based on its independent variable. And this is where it gets really interesting and cool in my opinion. Let's read D and then we'll look at the scatter plots. D says, which prediction do you, excuse me, man. D says which which prediction do you feel more comfortable about? And then in parentheses, which scatter plot appears to have more correlation? And here is what I'm getting at with this. We know that for B and C, we plugged our 50% into the equations, and I found or predicted my Y value. So we have predictions for both, right? But what you have to always think is that not all scatter plots are created equal, okay? And that's what we didn't talk about yesterday at all. And you might notice, and I made two examples that were a little trickier than an obvious example, But both of these scatter plots even don't necessarily look the same, right? If I'm looking on the right side, where are most of the data points? They're all pretty close to the middle. You could say that no student really under or overperformed the test, right? Because most of the time, the students who did bad on the quizzes did bad on the tests, and we rise, right? You could think from last unit that there's not that much variability here, right? There's not that much spread of the data. Here, it's more spread, right? And farther away from the line. While we still can predict, it's not nearly as accurate in this case, right? So if you're looking at them both, look, this one has a bunch of points that are kind of far away from what's happening. And in general, even though a lot of the points are moving in this direction, they're still kind of far away from the middle, right? These students that completed all the problem sets were still getting under 50%. So this is still predictive, but it is really far away from the graph compared to the second one. So if I were to ask you now, and hopefully this makes sense, so if you're like, oh, which of my predictions would I feel more comfortable about? We have to believe the quiz score is more accurate, right? It's a better measure because this line, everything is closer to it. So I'd be more comfortable with my quiz average prediction, or the 63.4%, okay? And hopefully that makes sense to everyone. And the big idea is we don't say spread or variation or variability in scatter plots, we say correlation. Okay, so but it's the same thing as spread. If you see a lot of data points close to that line of best fit, you have a high correlation. There's a big correlation between quiz average and test average. If you don't see the data close to the middle, that would be a low correlation. Okay, and we're going to expand upon that first. we're going to expand upon that in a bit. Okay. So I wrote the quiz score prediction seems to be more accurate because there's a high correlation in graph 2. Okay, and we're going to get a statistic for this, the same way we have the standard deviation and variance, but hopefully that makes sense. When you're looking at a scatter plot, not only do you have to kind of see what would the line look like, but how accurate is that line even going to be, okay? And that's the big idea, but we're going to kind of expand upon this and detail this more. And E says to describe the correlation of each scatter plot in words and by estimating the correlation coefficient. So this is going to be our big statistic in this whole unit. The good news for this is that there isn't like the median, the mean, there isn't like 10 different statistics in this unit, there's only like 3, okay? But the correlation coefficient is going to be a number that describes the correlation. But before we do that, let's just go back and talk about what we were saying before and describe the correlation in words, okay? So we could say that this is high correlation. It's not perfect though, right? Because all the points could be closer to the middle. But if we were going to say how strong the correlation is, it's strong, right? This is a strong correlation. This one, we could say is a weak correlation, right? And what we're going to build towards is that there still is a correlation here, because you know, there's going to be graphs where there's no correlation at all. There definitely seems to be a trend of going up, but that trend in this case is weak, in my opinion. Okay, so you could be weaker than this, and you could be stronger than this. The points could be closer to this, but overall, this is considered a strong correlation. This is something that's considered a weak correlation. Okay. So I'm going to take a little notes first, but we have weak, moderate, and strong. Those are the 3 big words when you can describe it. And remember how last unit we had roughly symmetrical or roughly skewed? Our little cheat code here is going to be to use the word moderately a lot, okay? So you can describe it in 5 ways. You could say it's weak, moderate, or strong. But if it's not weak and it's not moderate, you could say it's moderately weak. And if it's in between moderate and strong, you could say it's moderately strong. And we're going to talk about all different examples today. but hopefully that makes sense to everyone. And then the second thing is that some correlation is going to be positive and some correlation is going to be negative. Okay, so we'll see in the next example an example of a negative correlation, but think here that as problem set average goes up, test average goes up, it's like the slope is positive. So when you describe the correlation, you're going to want to describe how strong it is and also if it's positive or negative. So it's a two-step process here, but those are the things you're going to do. Okay, so those are just small notes for this. If we're going to describe both of them, we already described the first one as weak, but it's also positive because the line's going up. If it's going down, that'd be negative. So one is positive, weak correlation, and the second one was positive, strong. And the second part of this is going to be figuring out how we can connect these words to a correlation. Okay, so we know that we looked at these, and even before this, you may have been able to guess, right? You may have been said, this is strong, this is weak. But this is a math class, and we have to find numbers to put here. And that's where this notes that I give you, I don't always give you notes, but these notes are baller, okay? So here's where you have to think. Read this, but this number R is in between -1 and 1. And how the closer you are to -1 or 1, the stronger the correlation is going to be. So first, we're going to talk about the positive example. So all of these have a positive R value. But if you see 0, that means there's no correlation. Your first goal, if you're trying to guess correlation, is to draw the line on. And while you might be able to draw kind of something that way, this to me really looks like there's no correlation. Maybe they should put a few more up there or something. So no correlation is equal to 0. But then as that number gets bigger and bigger and bigger, the correlation gets stronger and stronger. So 0.3 looks similar to what we just talked about. 0.3 is a classic weak correlation number. Okay, this one you definitely can see a line, no doubt. But there are points that are really far away from it. This is a strong correlation as we get closer to 1. So 0.8 is something that we consider strong. Okay, and then if you got 1, that would mean that it's exactly predictive. Okay, so that would almost never happen in real life, but if you're getting even a 90, that's really, really, really good. Okay, so hopefully that makes sense. It's pretty straightforward. And then just think the negatives do the same thing, but the correlation is now going down instead of up. Okay, so do you see how this graph, if I was to draw that line in, it'd be going down? That's going to tell you that this correlation is negative. Okay, so this correlation is a little stronger than this one, so it's a -0.4. So the concept remains the same. Okay, as you get closer to -1, the correlation is getting closer and closer to perfect. So 0 means nothing. As you get to 1, really strong positive. As you get to -1, really strong negative. And this is in your packet. And this was my little notes too. 0.3 is the perfect weak, is like a classic weak. 0.7 is a perfect classic strong, and 0.5 is a classic moderate. So if I wanted to predict both of these, know that the number corresponds with what you described it as. So if we say a positive weak correlation, that's 0.3. If we see a positive strong correlation, that's 0.7. Okay, and when we're predicting this, I'm going to give you the right answer. It doesn't need to be perfect. What we're trying to do is kind of look at enough scatter plots so that we have this good instinct about what the number is going to be. Okay, so what we see on the next page is actually similar to like what a lot of these questions are going to ask, and that is just to match scatter plots to their correlation. Okay, so we have 6 scatter plots in this case, and we want to match them to a correlation. And for now, I'm giving you the words and the R so that you start getting them so that you start really thinking when you see 0.9, it means strong, really strong positive. When you see -0.3, it means pretty weak negative. Okay, but eventually this would go away, and you just have to know what these mean. So there are many approaches to this, but one way is that we can figure out which ones have really strong correlation first. So we know that these two are really strong. Probably the strongest, right? This one is decently strong, and none of these are that strong. So this is my strongest positive, right? And this is my strongest negative. Okay, so I changed some of my minds a little bit. Let me clarify. First, I typoed, and when I typo, it's usually corrected by the time you get the worksheet, so that's kind of a good thing about these videos. But first, this is my strongest negative, so it's going to be our near perfect negative correlation, and this is really close to being perfect, but there is a little bit of variation, so I'm going to call this negative 0.95, okay? So that's how we know this is going to be 6. And then I'm also going to look for my strongest positive, right? This one's going up, so it has to be positive. And if it's a strong positive, we know that that's going to be something like 0.9. And hopefully you guys are like, oh, this is going to be really easy. Because yes, it's going to be really easy. This one's negative and moderately strong. I'm not even looking at this stuff now, but this is moderate. Yeah, moderately strong negative, perfect. So this is going to be 5. And then we have the less correlated ones to deal with, okay? And the way we're going to do that is still figure out what is the most correlated. Of these 3, this one looks pretty more correlated. This is a positive, and this is the next strongest of any of these, right? This is going to be a moderate positive correlation. So compared to the other ones, this looks a little weak to me too, but there's a definite trend going on. So this would be a positive. Maybe I'd think more like a 0.4. This is negative, but still exists. This is negative, but very weak. Weaker than this one, I'd say significantly. And this was going to be our weak correlation, number 4. And then finally, this one has not a lot of correlation. And I was looking at this a little bit and I was overthinking it a bit because you can see kind of a trend down, but if you really wanted to, you could kind of see a trend up too. Okay, so this is, if anything, a little bit down. And if there were like 2 more points, it would easily be a 0 correlation, in my opinion. Okay, but if this is a very low correlation, when you can't immediately see what's happening, think that that's going to be very close to 0. All right, so that's the video. I crushed it on being concise again, and hopefully this lesson makes sense.